Hi guys, my name is Ivo from mytestedasp.net. Since a lot of people requested to make a video about C# delegates, I decided to create not a one but three. This is the first one, which will be about the simple delegate keyword and how to use it in your code. The second one will be about the built-in C# delegates action and func, and the third one will be about events, because with events you always use delegates. Okay, let's start. I have a project basic delegates and I would like to use the delegate keyword. Normally, delegates are created and defined outside of classes. They are an entity of their own. So if I want to create a delegate, I can create one the same way I am creating classes. Public delegate something else. I can create a delegate in a separate file too, my delegate. So I'm going to create the delegate in a separate file because the best practices of the C# language says that each entity should be in a separate class, in a separate file. So what exactly is a delegate? If I create a delegate, delegate is essentially a variable holding a function. I will let that sink in for a minute, because if you're not used to delegates it may be a bit weird. But imagine how you can say var number equals 5. Then this number 5 you can use it around your code. You can pass it. You can pass it to other methods. You can change it. You can change it. You can apply some operators on it and so on. You can compare it, for example, call to string and so on. Imagine the same way you having a variable, but this time holding a method here. For example, if I have a method public static void print integer, which essentially prints the integer, imagine how I can use the variable to save the method and then use it later, or invoke some operations on this method or pass it to another method. It's a bit weird, but yeah, the essential usage of delegates is to store methods as a variables, and that's it. So if I create a delegate, I need to provide a signature of what kind of methods I will be able to store in that delegate. So I will create a void delegate, which essentially means that I will be able to save void methods, and then I will say what kind of parameters I will be able to save in the delegate. So when I create a public delegate void my void delegate int number, that means that I will be able to store in this delegate each method which is a void method and has a single parameter of type int. That's it. So essentially from now on I can store both these methods in that delegate. Let's write another one. With a string to see how it won't work. How to store the methods in the delegates? Essentially the same way you're creating a class. You can say my void delegate, my delegate equals new my void delegate, and you can pass a function here. You can pass a method. So essentially it's the same way you're creating a class, nothing different. And now this variable here stores the method, and you can use it. You can use it later, for example. Later, and you can invoke everything is stored in the delegate. And I can say, okay, let's invoke the method with the number 5. And my delegate will invoke the method I'm storing in it. Yeah, currently it's not very different from just calling the method here, but remember that with delegates you can pass them around like a variable. So if I have a method which expects some delegate, I can call that method here and I can pass it. I can pass the delegate directly here, which is the cool thing of the delegates. You can pass functions around, and you can create a very abstract code just by using delegates and saving a lot of if-else checks, for example. Your code will look better and will be following the solid principles better. For example, you can use it for the strategy design pattern, but that's a whole another topic. So essentially, when you are saving a delegate, you can pass it around. And if I say that I want another method here, which just prints my int plus 10, if I say that my delegate has another method here, I won't change the passSomeDelegate method because it will continue working. So it will print 15. Basically, the delegate stores a method, and that's it, and stores it in a variable, and I can use it whenever I like, and I can pass that variable to other methods. That's the coolest thing about delegates. And delegates are type checked, they are strongly typed as almost everything else in the C# language, and I won't be able to save a method which is not void method and which does not have an int parameter. For example, I won't be able to save this method in the delegate because it does not match the signature. If I want to match that signature, I will need to create public delegate void my void delegate with string, for example, which allows the parameter to be of type string. So I will use the other delegate, but I won't be able to pass it here because that's another type, and that's completely normal. So essentially, if I want to save public static string method, some other method which gets two integers, I will need a delegate. I will need a delegate which returns a string and receives two input parameters of type int. That delegate would be and currently I will be able to create a delegate from the method which returns two strings and which returns a string and gets two integers as an input. Nice. Okay, what else can we do with delegates? Delegates can store not a single method but multiple methods. So if I want, I can store in a single delegate 10 different methods, and when I invoke the delegate, each one of these methods will be invoked in the same order I save them in the delegate. Let me show you. But first I want to show you that there's another syntax of creating a delegate. You can create a delegate like this too. But if you want to use var, you will need to use the new keyword. So let me show you how to add multiple methods in a delegate. It's done by using the plus equal operator. You can add a method as long as it has the same signature. I will also add the print integer. And if I decide to invoke delegate with the number 100, for example, each one of these methods will be invoked in the same order I save them in the delegate. So when I run this, I will receive 100, 110, and 100. Exactly print integer, some method which adds the number 10, and print integer again. And you can delete methods from the delegate too. So when I call minus equals some method, that means that only the other methods will be called from this delegate, and that's very cool. So whenever I like, I can create a delegate from a method and then add and remove other methods which have the same signature as the delegate. You can also add anonymous functions by using lambda expressions. You can say, okay, I want to print the number, I want to print inline func. So I can add as many inline funcs I want into the delegate and it will invoke them. The bad thing about inline functions or inline methods like this one is that you cannot remove lambda expressions from the delegate. So essentially you are not able to extract the same, because for the C# language this method and this method are two different methods and it will not understand how to remove it, because this method is not this method, although their body looks the same. That's exactly the same situation if we have two methods with different names but they are doing the same thing. This is the situation here. So essentially the delegate won't recognize the expression and won't remove it from the list of delegates. Okay, great. And that's the basic of delegates. I will show you a couple of options that delegates have when we decide to see what they provide as properties or as methods. But first I would like to thank my sponsors. As you may already know, I am a teacher and a CTO, and in my free time I create open source libraries for ASP.NET. For example, this one. Most of my libraries are fluent testing libraries, allowing easy, strongly typed assertion of your web application. You can test and assert controllers, services, models, databases, and more with a very easy, fluent interface. My projects are developed for more than 3 years now, and they're supported on Patreon and Open Collective. So if you want to support me, I will be very thankful, and you can choose one of these sites to contribute or donate if you like my videos or my projects. Currently I have two companies which are sponsoring me, that's Softtuning and Smart IT, and I'm extremely thankful for you guys. Okay, let's return to the code. The delegate has Invoke, which essentially does the same as the line here, so these two lines are exactly the same. They do exactly the same thing, so it doesn't matter which one we're going to use. This one provides no checking. If you are not sure whether the delegate is null or instantiated, you can use that operator. So if I want to be sure that this method will not throw if a no delegate is passed, I can use the question dot operator. Cool, that's the invoke. You have dynamic invoke, which is slower, but that should be used when you are not familiar with what kind of delegate you are using exactly, because you can use the base delegate the base delegate uh, the base delegate class to represent all delegates. That's essentially polymorphism, but you won't be able to invoke it directly because that's not strongly typed. You don't know whether the delegate is of this type or of this type or of this type, so you cannot invoke it directly, and you cannot invoke it without dynamic invoke. And dynamic invoke tries to bind the parameters you're passing. For example, if I uh, pass this delegate and try to dynamically invoke it without providing any parameters, and as we know this delegate expects one integer parameter, I will receive an exception, parameter count mismatch. If I pass, because I can pass whatever I like, if I pass the wrong parameter, I will receive an exception. System string cannot be converted to int32. So to make this dynamic invoke work, I will need to use the correct signature, but that's not known during compile time because it's a dynamic invocation. Even if I pass more than one parameter, I will receive the same exception. Dynamic invoke is maybe 10 times slower, so use it only when you're not sure what the delegate type is. Dynamic invoke can be useful, but try to make your code strongly typed so that you can use the fast invoke method. The invoke method is as fast as a normal method, so that's cool. And it has a compile time check because currently it says, sorry, but my void delegate does not allow two parameters. It needs to be one. Great. So I showed you invoke, I showed you dynamic invoke, and the last thing I want to show you, besides the method which just returns the system reflection method information about the method, I want to show you the target. The target is the object on which the method on the delegate is called. So if I try to see If I try to see which is the target, currently I will receive no, because the methods are static and they don't have an object. So okay, but let me show it like this, because this method has an object. Lambda expressions has an object, and that's the object here. So I will remove this to make the example more simple, and I can see it's no because I'm calling a static method. But if I create public class cat and I say public string name, for example, and public void some cat method which has the same signature, and if I create a cat and then I say void delegate plus equals cat dot some cat method, and if I call that, I will see that the type is cat. So the target is this object here, the cat. That's the target. The target is the object on which the method is called. Currently is on the cat object, but if it's a static method, the target will be no. Okay guys, that's pretty much about the basic delegate keyword. There are some better ways to use delegates in the current C# language version, but I will show them in my next video. Thank you again, and don't forget to hit the thumbs up button or leave a comment below if you like this video, and I will be very thankful for whatever help you can provide me with my projects, no matter whether it's starting the projects or becoming a sponsor or backer on Patreon or on Open Collective. It doesn't matter. I will be extremely thankful, and that's pretty much it for now.